Okay, we should be good. Okay, so brief recap. So today we're going to try to build a four-bar to allow us to like lift things in a linear manner, sort of like this, right? Because like with our current setup, like with a two-bar, it lifts in an arc. So that means if I'm lifting this object, it will go in an arc as well. It'll kind of lift like this. But like, what if we want to lift in a straight line for like different applications, we're going to have to build something different. So one of the most simple and most effective solutions is the four-bar. And it's not too different from what we have here. We can, in fact, just take what we have here and build on it, and we'll be done really quickly. So, as usual, it's powered on this side. We're just going to, the idea is to add another C channel on the bottom. So, like last week, it was kind of confusing at first, like before I finished building this, like how it works. So this week, I'm just going to show you what it is first and then build it. So hopefully it'll be a bit more clear. Let me share this one. Okay, share. I'm just gonna share my entire screen. Whatever. Alright. I hope you guys can see this. So this is Team 5225A. Like, they're freaking like world champions, right? So like, we're talking about like a really, really solid team here. Okay, so what they built for last season is something pretty interesting. So they built a four-bar here, which is basically, it's kind of hard to see in this picture, but basically this is a lift, right? So you can see it kind of looks similar to our two-bar where it kind of goes like up and it goes down, but you have like two sets of C channels here. And let's see if I can find a better picture. So I'll just show you the video. Okay, so let's just look at this. So this is their programming skills. You can see how their whole thing like goes up and down. And the lift mechanism with which they do this is the four-bar, which we'll be looking at today. So you can see how they went from the high position to the low position. And you can also notice how it lifts in a linear fashion. It doesn't like swing outwards like a two-bar. So that's something to pay attention to as well.
Did you make it the same as the auto deploy? Same as the auto deploy?
Oh wait, okay, let me correct this. It does swing outwards, but like it keeps like the part on the front, it keeps it linear, right? So like when it lifts up, like if the tray is like straight, like it keeps it linear. It doesn't that's basically that emotion. It basically holds something straight to the ground. So okay, let's just go back to Inventor. It'll be like, because their tray tilts is kind of trippy, but don't worry, it'll make sense. So because they had two sets of C channels here, like one, and they had another one below, we're just gonna do that real quick. Okay, alright, I'm just gonna put this on the bottom. And as usual, if you guys have any questions, just dump them in the chat or open your mic and we'll answer. So like if you put like a gear like on the bottom now, so this pinion effectively powers both of these. And these will both spin in the same direction as well, the two big green gears, by the nature of how it's geared. So that's really nice. Just gonna put this bearing on here. Does this like chafe a bit? Yeah, it does. So I put it on the wrong side. So it doesn't clear here. I'm just gonna put it on the other side. No big deal. Wait, what? Oh, I see. There's a shaft here. Let me just ground that. So like what's happening, I was clicking the shaft instead of the bearing because they're really close to each other. And this time I'm gonna rotate it out of the way so I don't click the shaft. And as usual, we can put a screw joint down so this thing is jointed to the C channel. And yeah, so basically that's one side. And you can start to see it's kind of starting to resemble uh, the pylons robot. We're just gonna mirror this on the other side, which should be really quick. So again, you can hold down Control and select multiple components, and you can just yeet it on the other side. So copy paste. An interesting note that if you copy, all the constraints will be copied as well. But if you like choose if you do Control X, Control V, that means the constraints will be removed. So that's something to keep an eye out for. So when you copy, like just to iterate it, when you copy it, like a lot of components that are constrained together, if you copy, the constraints will stay together. If you cut and paste, the constraints will delete themselves. So there's just something you'll notice coming down the road. I don't think we need pinions there because we're just powering this side, so we won't worry about that. And then we're gonna use the angle constraint to make sure these bars are parallel. Okay, and we just do this to the other side. Okay, so what should happen is, yes, very nice. So you can see these two go up together, and when the motor powering this gear is spinning, because these two gears will be spinning in the same direction, right? So if it spins one way, it'll go down, spins the other way, it'll go up. And these bars are just floating right now. IRL, these would just be actually no, this would work IRL for sure. We can add a brace on the bottom, or we can put a pinion to link these. I think we should link these. Even though we're not powering it, just linking those gears just makes it more symmetrical, and that way this mechanism will be more robust, I can say. But you can also do that with racing. So typically you gear both sides. That's my bad. And I'm cantilevering in this case. IRL, you should probably put another brace here, but maybe I'll do that later. So yeah, now you can kind of see that's the basis of it. And now to make this achieve the effect that we wanted last time, we want to lift something while keeping its direction, because how do I, yeah, let's just take the motor again. We want to lift something without changing its direction, right? Without changing how it's oriented. So right now you can see this is parallel to these C channels. When it lifts this up, we want to be still parallel to those C channels. Whereas if it was the two bar, it will change angles, where it'll kind of swoop like that in an arc. So to do this, we just need to add two more C channels and we'll be done. I think the right size would be 10. Let's grab these. These look a bit too small. We'll just try them. Okay, and since we're doing screw joints or whatever, you always want to put bearings on joints, on shaft joints, on screw joints. You always want bearings. Or else you have screws grinding against metal, which is a lot of friction, and it actually starts to carve out the metal itself. So that's really bad. Just put them here. Okay, and let's grab some spacers. Okay, I'm just gonna pop them onto the bearings. And finally we put these on. So we put this here, and then I need to find where it lines up exactly. So like if you're moving a component that's attached to something and it's moving as well, you can just ground it so it doesn't move, and you can like, oh interesting. Never mind, I'm gonna unground this. I'm just gonna count holes on this side. So between this you have 1, 2, 3, 4, 5. So there should be 5 holes between this. 1, 2, 3, 4, 5. Okay, I think it's this hole. And if it doesn't work, we just try a different one. Yeah, it didn't work. Or we can, yeah. Let me count 5 holes again. 1, 2, 3, 4, 5. It should be this one. Is it not? Okay, that's really strange. That's very interesting. What I'm gonna do is this. I'm gonna put a temporary constraint. Oh wait, I think I know why. Okay, so it might be because the spacing on this side. Let me just, you can, remember you can check your constraints like show, and you can click this, okay. And then I'm gonna show these as well. Okay, the constraints on these seem to be okay. Huh. Alright, I'm just gonna do what I was doing before. So I'm gonna constrain this at a right angle to this, just so I can see this better. Actually, no, I'm gonna constrain, yeah, 0 degrees. So it's gonna be like it's halfway up position, and we're gonna try again. Because like now these like are locked, it should let me rotate this. Okay, why is this being weird? Let's undo this constraint and put it on again. So you might like, I don't know if this is an Inventor issue, but like you might notice like sometimes when you ground components or when you like constrain components, like things are supposed to be allowed to rotate, like they don't rotate. It's pretty annoying sometimes. Like here, like clearly like in real life this should be rotating, but it's locked for some reason. You can actually get around this by using your ground functions. So you can show this and then remove this and then ground it there for now. We're gonna fix that later, but I need to gauge where this is lining up. So now it's gonna let you rotate. And it should be lining up there. And hopefully it'll let us pop it on. Okay, the clearances don't line up. Huh. This is really strange. Sometimes Inventor does really strange things. Okay. Oh, do you guys see what I see? Like there's a gap between here. That's why it's like screening all that. Okay, to fix this, let me think. Alright, it's actually pretty simple. Because IRL, you have play like here, you can probably get away with this sort of spacing, or you just spam like Teflon washers or like steel washers, and you should get away with it. But because of this Inventor, they want everything to be perfect, we're gonna have to deal with it. So again, I'm just gonna get rid of this constraint. So that means I can move this around. Did I do the wrong one? Right, actually I'm gonna delete this and I'm gonna put this back up there. If I remember correctly, it should be this hole. We're gonna pop it on here. And since I removed the previous constraint, I can just constrain this on. What? Okay, sorry guys. I don't know why Inventor's like this. Hold on. I remember I grounded something. What did I ground? I grounded this. Oops, wrong side. We need to select the right side. Okay, so now I think it worked. And I just have to attach these two together. So I take this, boom. And as you can see now the gap is kind of filled. This is sketchy, like in real life you'll fill spaces whatever, but CAD everything has to be perfect, so I had to work around it. And now we can get rid of the angle constraint we just put and finish off the other side. So again, show, you can see all your constraints, delete the angle, and you should be able to move this up and down again. Yeah. Okay, so now we just do this on the other side. And since there isn't any spacing issues like on this side, we can just smack it on. So we go here, and then we do it to the other hole. Okay, and we are done. And hopefully, oh, this looks bent. I think I did a wrong hole, probably. Okay, this is straight, that's bent. So one of these are, oh, I see. The gear is like kind of slipping out, so we can fix this by, right, okay. I think it's time to show you guys another technique. So, okay, so I talked about cantilever this side. Cantilever is generally bad, but if you do it like properly, like pylons did, then you should be okay. But for good build quality sake, I'm just not gonna cantilever this and just fix this side. And this will in turn make it line up better because I can't use that side to constrain. Oh, I selected the wrong C channel. We are almost done. Okay, and we'll just do on this side what we did to the other side. I'm trying to think if there's a better way to fix this alignment because right now my case is I can't constrain this to this side. I'm gonna have to make it aligned somehow. This is constrained to, oh, okay. There's a way to fix this, I think. Okay, what I'm gonna do, because again, like, this is not lining up perfectly, that's a nuance on Inventor. It's kind of annoying sometimes. I'm just gonna get rid of this for now, and this will allow me to like actually mount these gears onto that side. So you see it's already mounted like that. Okay, that's fine. I'm going to have to do this. So let me use the free move command. It's right there. Move this out. And we're just gonna constrain these together. Okay, and we're just gonna do this to the bottom gear as well. I think it's already done for the bottom gear. Yeah, it is. Yeah, I'm just gonna have to constrain the spacer onto the C channel. So you can see how it's kind of like flying out here. Just gonna take this. It should be 1, 2, 3 down here. Boom. Like that. And finally, we make these line up, so we can do an angle constraint between these two. And make it 0 degrees so they're parallel. And it's basically the same thing as before, but everything's lined up. And we can hide our constraints here, and we should be good. So yeah, this is basically the fourbar. Since we're done building it, I'm just gonna run through it really quickly. It's really similar to the two bar. It's two bar like 2 times 2, 4, very similar. Basically two bars. It's generally powered by 1 or 2 motors depending on the application. For example, in the zone, you would use 2 V4 motors, but V5 motors are pretty strong, so you can get away with one on 200 RPM cartridge or 100. Usually 100 because more torquey. You have this pinion gear. When spinning, it rotates these gears. Again, we have small gear going to big gear, so we're favoring torque because lifts generally are lifting pretty heavy objects, and it causes in turn these to move. And if you notice, these C channels form a parallelogram, which means this side and this side will always be parallel, because that's what parallelograms are. So this basically gets us what we want. We can lift an object without rotating it, if you see what I mean. So this is basically how it moves. And that's just basically the fourbar. Again, like building like fourbars, you want to put more bracing on it. So like where are these going across? There's also like other braces like X braces and K braces you can do, which we'll go over next time. So yeah, this is basically the fourbar. Sorry for all the technical issues. Inventor is like kind of like this sometimes, so you need to know how to work around it because again, everything needs to be perfect. And yeah, do we have any questions? Or do any other execs or Victor want to add anything to this? Yep.